All right, this should work just like this. Can we see? Hopefully we can see a little bit. Okay. So, here it says determine whether the function is a polynomial function. Is 6x to the fifth minus 1/2 x plus 4 a polynomial function? Yes or no? Yes, it is. It is a polynomial function because we're not dividing by a variable. We don't have a variable to a negative power or a square root or anything like that. So it's a polynomial function. What's the degree of the polynomial in this case? 5. And the leading coefficient is 6. It's a coefficient of the highest degree term. All right. Match a graph of 3 times x minus 1 quantity squared minus 3 to the graphs below. Well, if it's a 3 out front, what do we know? A positive 3, it will open up. So it's not A, it's not C, and it's not F. Okay? Where is the vertex? 1, -3. 1, -3. Okay? Because it's the opposite of this, the same as this. Well, B is the only one that now will work because these are both negatives. Okay? So, vertex is at 1, -3. In addition, the correct graph opens upward. And it passes the points 0. Well, if you put in a 0 here, 1 squared is 1. 3 minus 3 is 0. So it passes through 0, 0. Also looks like it passes through 2, 0. So if we test that, 2 minus 1 is 1. 1 squared is 1, and so on. So it passes through 2, 0 as well. Okay? X squared minus 10x plus 29, complete the square. Okay, so those of you who are in Algebra 2 anybody in here in Algebra 2 right now? No, the Algebra 2 kids came begging for help yesterday because Miss Wheeldriver was gone. So it was like, hey, how do you complete the square? Well, you take x squared minus 10x plus blank plus 29 minus blank. Whatever you add, you have to subtract. So you take half of this and you square it. What's half of -10? 5. 5 squared is 25. So we put a 25 here and a 25 here. So if we factor this, this is x minus 5 quantity squared. 29 minus 25 is plus 4. X minus 5 squared plus 4 is choice B. Where's our vertex? 5, 4. It's an upward parabola. Axis of symmetry is x equals 5. So 5, 4 over 5 up 4. Its vertex is here. Now, does it have a first term coefficient? No. So its first term coefficient is 1. So basically, dang it. So basically, you can go over 1 up 1, over 2 up 4. And that's where your parabola will be. Where is its x-intercepts going to be at? Not going to have any, are they? Okay? Not going to have any x-intercepts because it's going to be above that. The parabola does not intersect the x-axis. All right. All right, so we have the power function 1/2 x to the 4th power. What's the power? 4. What's the constant of variation? 1/2. Okay? So should it open up or down? Up. And so it should be kind of wide. It should be like b, 1/2 x to the 4th power. Because the higher the power, kind of the wider it is. Okay, what's the domain of that function? Can you put any number into 1/2 x to the 4th for x? Yep, you sure can. So the domain is negative infinity to infinity. What's the range? Just looking at the graph. 0 to infinity. Okay? Would it be an even or an odd function or neither? Well, even function, because this is an even power, okay? An even power. And so if it's reflected across the y-axis, if it's a perfect reflection across the y-axis, it's an even function. All right. How would you transform the x cubed graph to be 2x minus 5 cubed? Okay. The x cubed graph goes through here, 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 and here. 2, 8, 1, 1, 0, 0, negative 1, 1, negative 1. Whoa, you're not supposed to straighten out on me. So let's try that again. So 2, 8, 1, 1, 0, 0, negative 1, negative 1, negative 2, negative 8. Okay, that's the original x cubed graph. So what's the minus 5 do to the graph inside parentheses? Moves everything to the right by 5. 1, 2, 3, 4, 5. So 0, 0 goes to 5, 0. What does the 2 do to it out front? Stretches it vertically. Stretches it vertically. So instead of being over 1 up 1, it's over 1 up 2. Instead of being over 2 up 8, it's over 2 up 16. Way up there somewhere. So it looks like this. It's even skinnier than that one is. Okay? So it's translated 5 units to the right and stretched by a factor of 2. Stretched vertically by a factor of 2. What's our y-intercept going to be? How are we going to figure out what our y-intercept is going to be? Well, your y-intercept occurs when x equals what? 0. So we're going to plug a 0 in here. If we plug 0 in here, 0 minus 5 is negative 5. Negative 5 squared cubed is negative 125. Take negative 125 times 2, negative 250. Okay, our y-intercept will be at negative 250. 0, negative 250. Are we good with all that? Okay. Now, the easiest way to do a problem like this is figure out where all the x-intercepts are. Where are the x-intercepts? 1, negative 3, negative 4. Will it bounce at any of them? No, it's not going to bounce. It will cross at each one of those. It's going to cross at each one of those. So you're going to cross at 1, negative 3, and negative 4. It's not this one, because that's cross at 1. It could possibly be this one, but it's probably not that one. It could definitely be that one, and it's not that one, so I would say it is choice C. It is choice C. So since we know it's choice C, then we can answer this next one, the end behavior. As we're going to negative infinity, what's happening to the function? Going down to negative infinity. As our x values go into positive infinity, what's happening to the function? Going to infinity. So infinity, infinity, negative infinity, negative infinity. So I guess it is choice D on this one. Whoa. Now we need to find the zeros of this function. What's the easiest way to find the zeros? I think factoring for this one. If we factor out an x, we're left with x squared minus 2x minus 3. So it's x minus 3 and x plus 1. X minus 3x plus 1, because we got x squared plus 1x minus 3x is negative 2x minus 3. So what are our zeros? 0, 3, and negative 1. Okay. Synthetic division. What goes in the box? 3 or negative 3 in this case? Negative 3 goes in this case. And so we have 3, 12, 8, negative 9. 3 drops, get out of there. 3 drops down, you get negative 9. 3 drops down, you get negative 9. Negative 1 drops down, you get positive 3. And you get negative 6. So 3, 3, negative 1, 6. Now this was r to the third, so this would be r squared. You drop by 1 power. So 3r squared plus 3r minus 1 minus 6 over r plus 3. So that would be this one, C. The remainder theorem. Again, synthetic division. 1 is there. 2, negative 9, 11. 2 drops down. 2 times 1 is 2. Negative 7 drops down. 7 is there. Negative 7 is there. 4 drops down. We have a remainder of 4. Would 1 be a factor of this function? No, because you have to have a remainder of 0 for it to be a factor. Factor theorem, is 6 a factor of this? Well, actually, we're checking if negative 6 is a factor, because x plus 6 gives us negative 6 as a root. So is negative 6 a factor of this? Well, you go 1, 10, 19, negative 30. 1, negative 6, 4, negative 24, negative 5, 30, 0. If you get a 0, is it a factor? Yes, it is. Rational roots theorem. Okay. 15. What are all the factors of 15? 1, 3, 5, and 15. What are all the factors of 1? Just 1. So it's all the factors of the last term divided by all the factors of the first term. And it's positive and negatives of each. So it is choice B. Which ones work? Well, you cheat on this. You look at the answers and you think, well, there's got to be 3 of them. So it's either negative 1, 3, and 5, or 1, 3, negative 3, and negative 5. So we'll try 1 first. And we get 1, 7, 7, negative 15. 1, 1, 1, 1, 8, 8, 8, 15, 15, 0. Hey, it's 1. So it must be 1, -3, 1, -3, 5, -15, 0, and -5. So it is choice D. Write that polynomial function. All right. So x minus 6 and x minus 6 is x squared. Outers is -6x, inners is -6x minus 12x plus 36. Okay? That's the first two. Now, I would use sum and product of the roots to figure out what 7i and -7i are. What's the sum of 7i and -7i? 0. So it's x squared plus 0x, or minus 0x, doesn't really matter, 0 is 0, minus 0x, plus the product of the roots. The product of them are 7i and -7i, which is -49i squared. What's -49i squared the same as? Plus 49. So it's x squared plus 49. Okay? So if we FOIL this out, it would be x to the fourth minus 12x to the third plus 36x squared plus 49x squared minus, 12 times 49, I don't know what that is. It's 490 plus another 98. What? 588? And then 49 times 36. So the only two terms we have to combine are those two. So it's x to the fourth minus 12x to the third plus 85x squared minus 588x plus 1764. There we are. What are the zeros of the function? Well, they're 6, -7i, and 7i. What are the x-intercepts? Well, there's only one x-intercept, and that's at 6, because that's where the 0 is. Okay, the i's don't have x-intercepts. Okay, polynomial function here. 5 multiplicity of 2. So it's x minus 5 times x minus 5 times 7 plus 1. So it's x minus 7 plus I and x minus 7 minus I. But we'll use sum product of the roots for that. So this is x squared minus 10x plus 25. What's the sum of 7 plus I and 7 minus I? 7 plus 7 is 14x. They're a product. 7 plus I, 7 minus I. 7 times 7 is 49. Outers, inners cancel. I times I is I squared. So 49 minus a -1 is 49 plus 1, or it is 50. So x squared minus the sum of the roots x, so it should be minus 14x plus 50. And then you have to triple distribute that. So it's x squared minus 4, or x to the fourth. If I take x squared and distribute it through everything, x to the fourth minus 14x cubed plus 50x squared. And then 10x times x squared is negative 10x cubed plus 140x squared minus 500x And then 25 times all of them is 25x squared minus 25 times 14. 350. I was just about there doing math in my brain there. Plus 25 times 50 is pretty big. 1,250. So if we add them, it's x to the fourth minus 24x cubed plus 75 and 140 is 215x squared minus 850x plus 1250. Okay. Did I make any mathematical errors? That any of you see, right? They say 7i is a zero of that function. So what are your zeros? Well, 7i is a zero, negative 7i is a zero. So what's the sum of 7i and negative 7i? 0. What's their product? 49i squared. So it's x plus 49, x squared plus 49 is the function you get from those two. So if we do long division here, x squared plus 49 divided into x to the fourth plus 44x squared minus 245. What times x squared is x to the fourth? Well, x squared is. So you get x squared, x to the fourth plus 49x squared. Change the signs and add. So it's negative 5x squared minus 245. What times x squared is negative 5x squared? Well, it's minus 5. So it's negative 5x squared minus 245. With change the signs and add, you get 0. So it's x squared minus 5. So what are the zeros? Well, they are negative 7i, 7i. And then to solve this, x squared minus 5 equals 0. So x squared equals 5. And take the square root. It's positive square root of 5 and negative square root of 5. The long division there. So the linear factorization of this should be x minus 7i, x plus 7i, x minus the square root of 5, x plus the square root of 5.
Wait, wouldn't it be 200 and 490? Negative 490 instead of 0?
No, because I changed my signs and added. It's negative 245 plus 245. Yep. All right. What's the domain of this function, 1 over x plus 9? What's the only number you can't have? Negative 9. So the domain is all real numbers except for x cannot equal negative 9. So the graph of the function, negative 9 is a vertical asymptote. So the graph of the function would look like this. whoop, and whoop. So as you approach -9 from the left, this says we're approaching -9 from the left. As we approach it from the left, where are we going? Negative infinity. As we approach it from the right, where is it head? Positive infinity. Okay? So it looks like that. If you need to, just graph it on your graphing calculator, and that should hopefully help you. Okay. Do we have horizontal asymptote? A horizontal asymptote here?
Yeah.
Yep, we do. If the bottom power is higher than the top power, the highest top power, then our horizontal asymptote is at 0. So it's y equals 0. It's the x-axis. Okay, y equals 0. Do you have any vertical asymptotes here? Yeah. Yep. So you factor it. X minus 4, x plus 2. So our asymptotes are at x equals 4 and x equals -2. So there are two. The left one is x equals -2. The right one is x equals 4. If you do not put the x equals in there, it'll be counted wrong. It's an equation, okay, to find a line. So you need to put an equation in there. X-intercepts. How do we find the x-intercepts? Well, we set the numerator equal to 0. We set the numerator equal to 0. What do we get? 1. So the x-intercepts occur at 1. The y-intercept occurs where we stick a 0 in for everything. If we stick a 0 in for everything, I get a -1 over a -8. A negative divided by a negative is a positive. So the y-intercept is at 1/8. So we have vertical asymptotes at -2 and 4. It crosses at 1. X-intercept is at what? I forget. 1. And then y-intercept at 1/8. So I think it looks like C, but I'm not sure. I would just graph it out to see for sure, but I think it's C. All right, and then the last step we had, solve this algebraically. Well, if my least common denominator is x minus 2, then I just go x minus 2 times on this side, times this one, and times this one. So I multiply. So x times x minus 2 plus 3x equals 6, because the x minus 2's cancel here, the x minus 2's cancel here. So x squared minus 2x plus 3x minus 6 equals 0. So x squared plus x minus 6 equals 0. So it's x minus 2 times x plus 3 equals 0. So x equals 2 and -3. Now
It
you
should be minus 6x, not minus 2.
What do you mean?
Because then you distribute it.
I distribute what?
Wait, never mind. Never mind. I was looking at it wrong.
Okay. So you get 2 and -3. What do you always have to do in these problems? Check your answers. If you stick in 2, that makes the denominator 0. So that's an extraneous solution. Stick in a -3, that'll work. So -3 is your answer. Because this is -6/5. This would be -9/5 and -3. -3 plus a -9/5 is a -6/5. Does that make sense? It's supposed to make sense. -3 plus a -9 over -5. Oh, there we go. Equals 6 over -5. So it's plus a positive. So this is -15 fifths plus 9 fifths equals -6 fifths, which checks. Yep. All right, on this one, so we multiply the top by x minus 3 and x plus 1, because that's what this factors into, so these cancel. Multiply this by x minus 3, x plus 1, and this by x minus 3, x plus 1. So the x minus 3's cancel, x minus 1's cancel. So it's 3 times x plus 1 plus 2 times x minus 3 equals 4x. So 3x plus 3 plus 2x minus 6 equals 4x. So 5x minus 3 equals 4x. So if we subtract 4x from each side, x minus 3 equals 0, so x equals 3. If we stick a 3 in here, that does not work. So there is no solution for this one. And then what we hit at the end. The roots of this are -5, -2, and a +7. So on the number line, we go a -5, a -2, +7. Then we're going to test like 0 in here. Test at 0. So if we put 0 into the function, it makes this positive, and this negative. Positive times a negative is a negative. So if it's negative here, it should be positive here. It should be positive here. It should be negative here, because there's no double roots. So it's positive between -5 and -2, and then positive after 7. So that one. Where is it negative? It's negative less than -5 and in between 2 and 7. That one. For this one, okay, factor it. So we have x plus 4, x minus 4, and x minus 7. So our roots on our number line are -4, 4, and 7. So then if we check what 0 is, if we put a 0 in here, we get positive, negative, negative. A positive times a negative is a positive. So we're positive there, negative there, positive there, negative there. So where are we negative? Because that's what it's less than 0 is negative. Well, from negative infinity to -4, and in between 4 and 7. So 20 questions on this. This will take you most of the period on Thursday to work on this, to get this done. So after lunch now, you have the rest of the period to work on the practice test to see how you do. You can take the practice test multiple times and so on. So I will put the practice test out for you, and then you'll have the rest of the time to work. Okay, the practice test is out there. You going home?
No, I have a doctor's appointment.
Okay.
But I'll be gone for the rest of the day.
Okay. You too. Yeah. Yep.